Well, let's continue. Let's discuss the problem of Practice-Techron. So a bead, I'd like to recall that a bead is sliding along the wire, connecting two fixed points. And what is the form of the wire to minimize that time? So the motion should take the minimal time. Okay, so we are looking for the formula y equals y of x, and we want to find the form of the of this curve to obtain the minimal time. Okay, first of all, we must write the Lagrangian. So how to find time? Do you know how to find time of sliding? So let it be so the integral from a to b. Okay, so these points are fixed. So we have y of a equals alpha and y of b equals beta. Okay, to find time, we must divide the path, the distance by the velocity. So the distance is given by root 1 plus y prime squared. Yes, and we must divide by the instantaneous velocity, right, and integrate from a to b, dx. So now our goal is to obtain the formula for v. To obtain the formula for v, we must equate kinetic and potential energy of this point. So it has a potential energy which is equal to m mgh, so y, it will be y. Yes, this is a potential energy, and the kinetic energy is 1/2 mv squared. So, and this is the equation for y squared. So y squared will depend on y. Yes. Minus yes. So if we take okay, or if we just a moment. Yes, it must be. I think it must be minus. Yes, but just a moment. So the yes. So I'd like to put what to do. And maybe we will do the following. So suppose y is negative. Okay, so I think it's better to move this to the origin. Okay, so the best solution. So I don't want this to be complicated, too complicated. And so I will do the following. I will move this to the origin, and then I will consider the task when a is 0 and y of 0 is 0. Okay, and so if and now, so it is minus, of course. And now v, the formula for v will be so if we eliminate m, it will be root of minus 2 gy. And so t will be given by this formula over minus 2 gy dx. Yes. Sorry. Is it okay? So now it's okay, I think. So both parts are positive, yes? So minus, positive. Okay, so and if we make a change of variable, so I don't want to work with negative y, let it be positive, and so I will change y to negative y. Yes, or maybe, or is it difficult? Or maybe let's leave it in this way. So it will be the root of minus y. Let it be this. Let's try to do this. Yes, and so this is a fixed constant, and we will consider the Lagrangian in the form root 1 plus y prime squared over root y. Okay, and now we will write the Lagrange equation, but instead we can write the first integral obtained from lemma. So it was L. So since L depends only on two variables, then we can write then the consequence of the Lagrange equation in the form L minus Ly prime times y prime equals the constant C1. Oh, no y, but negative y, of course. Negative y, yes. It is negative y because y is negative. But I think it's better to make the change of variables, because now it is I will make a mistake when differentiating this, but maybe it's okay. Maybe we can try this. Well, 1 plus y prime squared root divided by root negative y minus, so the derivative with respect to y prime will be y prime divided by root negative y, root 1 plus y prime squared, and times y prime equals C1. Well, what shall we do next? Next, let's simplify this. Yes, let's multiply by the denominator, and we will get 1 plus y prime squared minus y prime squared. Yes, equals C1 times root negative y and root 1 plus y prime squared. I think it's this. And we have the following: root negative y equals the formula for the function y is the following. It is and times C1. Let it be 1 over C1 maybe. We must divide by root 1 plus y prime squared. And on squaring both parts, we will get the following: y equals, let it be constant, some constant times 1 over 1 plus y prime squared. So y is negative, and so our constant is negative. Yes, it's this. Am I right? So I'd like to check. Yes, it's okay. So now we will try to solve this. This equation again doesn't depend on x, and so as before, we must make some introduction of parameter. Yes, the introduction of parameter, like here. The parameter was given by this formula y prime equals shine p, but now it is more convenient to make the substitution of the form let y prime be equal to not p, but let it be the cotangent p, cot p. Then y will be given by the formula c times 1 over 1 plus cot squared p 1 plus cos squared p is equal to 1 over sine, so it is c times sine squared p. Okay, so from this formula I have dy equals cot p times dx. And from this formula, if I differentiate with respect to t, I will get dy equals c times 2 sine p cos p dp. And after this, I must equate these parts. So I will get the following. So I will move here, and I must equate right-hand part, and I will get, so quad is cos p over sine p dx equals c times 2 sine p cos p dp. And now I must solve this. So I can eliminate cos p, and after this I will get dx equals c times 2 sine squared p dp, and x is equal to the integral of 2c sine squared p dp. It is equal to the integral c times 1 minus cos 2p dp. It is c times p minus the integral of cos is sine, yes, so 1/2 sine 2p plus c2. So our curve is given by this formula. So y is equal to, so x is equal to c times p minus 1/2 sine 2p plus c2, and y is equal to p times sine squared is equal to 1 minus cos 2p half. Okay, this can be rewritten by x equals p half 2p minus sine 2p plus c2, and y equals p half times 1 minus cos 2p. And if we already note, so if we set t to be equal to p, and I will denote c half by c1. Let c1 be equal to c or c half. Then we will get the equations c1 times p minus sine t plus c2, and y equals c1 times 1 minus cos t. And this is exactly the parametric equations for the cycloid. Yes, so t minus sine t, 1 minus cos t is y. So the constants c1 and c2 can be found using the initial condition, but we have y of 0 equals 0. Yes, and so we may use this to find what? So y of, so if x is 0, then y must be 0. Y is 0 when p is, oh, so y to, so it's here. A moment. So if t equals 0, this is the initial point. We start with the time t equals 0, and so x will be equal to c2. So c2 is 0. C2 is 0, and that's all. So this is eliminated, and so we get this condition. So C1 can be found using the second condition, y of b equals beta. So this is the end of the example, the form of the cyclid. And next, I want to solve more problems on calculus operations. So like before, so I took the book, this one, okay. I think it is familiar for you. So yes, not. So I think I saw. So this is the problems, the books with problems and exercises. But I saw the course of differential equations. Last year, you showed me the course of differential equations. But this is the book with problems, right? And so we will take the problems from this book, and we will continue to solve problems. Yes. Let's start our seminar, and let's exercise with solving the Lagrange equation, finding the candidate for the minimizer, and then checking that this is actually a minimizer. So let's start with that part of the board. Okay. So let it be task number 4 from here. G of y. You need to minimize the following. The integral from 0 to pi 4. Dx with the condition y of 0 equals -1 and y of pi 4 is 0. Yes, so first of all, you must write the Lagrange equation. Yes, it's okay. No x here, yes, and so you may use this property, of course. So what is it? So shall I recall? Yes, recall the property. So since there is no x here, you may use the following equation: L minus L partial with respect to y prime times y prime equals C1, some constant C1. Well.
So I'll just apply this formula.
Yes. It is convenient to apply it. Do you want to solve something? Sorry?
Did we solve 2 different problems simultaneously?
Yes, welcome. You may try. And you, Daniel, do you want to be the third in this competition.
Sure.
But useful in the computer will be calculated.
Ah, yes. So task number 4. The same or
No,
different?
different.
Different. Ah, so number 5 then.
Yes.
You, Daniel.
Number 1. Can I do 1?
So number 1 and number. So the first 3 are for the homework.
Ah, okay.
Yes.
Can I do the homework?
Uh-huh.
Go to the homework now on the board. Yes.
So I don't want it.
I'll read a different question. How many questions are we going to do for the assignment?
So yes, I'm not sure. So it depends on you, I think.
I think
We will try.
just
Three?
I need to
Three?
help this as well.
Okay, so I will help Kasia, I think. Okay, well, let's check first. L is this. Yes. So this is the derivative with respect to y prime. Yes, it's correct. Multiplied by y. It is this. Minus, yes. And now you must solve this. And what shall we do to solve? I think like before, maybe. So you may try to introduce the parameter. So y prime equals p. Yes. So as before, maybe this will help.
Very helpful. It will be a function of sine and a logarithm.
Or maybe it is possible to integrate.
Yes,
So-
it's possible to integrate.
Yes, I think yes. So if you solve for y prime and then to separate variables, I think
Yes.
it's okay. So it will be root of from something. Okay, and maybe it is possible to. Oh no, I think not. Can't find the one. Yes, it is y prime. You may use this part of the board. So it is number 5, and what is it? It is 6.
I have no idea what to do.
I think maybe it is the most
Yeah.
difficulty.
I know.
But so first you should find the derivative of this with respect to y.
What?
With respect to y. So
we don't
there are 3 parameters: y prime, y, and cos and x. Y prime, y, and x.
So
First, you must differentiate with respect to. I will show you. So L prime with respect to y. So suppose this is constant.
8y.
Okay, 8y and plus.
So it's
Yes.
only if we don't have x, we need to follow that formula.
Yes.
But if we have
Only. Yes, but you can't use this formula.
And then we want to find the derivative of y tax.
Yes.
This is going to be only 2
So it's prime here.
y tax.
And yes, that's all. And after this, you must substitute this into the Lagrange equation, which is this: d over dx L prime with respect to y prime equals 0. So you must differentiate this with respect to x, and this will give you 2y double prime.
With respect to x, going to give us
Double prime, yes. So this it is not equal.
No.
So if we differentiate this with respect to x, we will get this. Yes, and now you must substitute this here, this expression here, and this expression here. Yes. Next, try to solve this.
Oh, I know how.
You know how well. Great. It's great if you know.
think so.
Uh-huh.
It's gonna be minus 3.
The most complicated is yours, yes. Uh-huh. So this is correct, yes.
Give me 2 minutes.
Uh-huh. No, long logarithmic function.
I think the answer is something like this.
X, uh-huh. Yes, minus x, a squared. Yes, uh-huh, it's this. Yes,
But I
correct.
don't have to find it up.
So just differentiate this and obtain this. It's the best, I think, the best way to obtain this formula. But you may make a substitution, maybe not cos, but but cosh, not cosh x. Yes, cosh t. A cosh t. Yes, this substitution will help you. Yes,
Okay.
exactly. Yes, this is the linear second order equation.
Please don't let it be, what's it called? Imaginary again.
Imaginary, yes. 2i plus or minus root 2. Yes. Lambda equals plus or minus root 2 multiplied by I.
So I'll find a particular solution here.
Yes. So this is correct. I think it's correct. So this is the formula for
We found
x is this, and then I think y is a hyperbolic function then. Yes, so this is the arc. So this is the area function. I know that if we make a reverse, yes. So if we try to solve this for y, we will get hyperbolic functions. And maybe it was reasonable to start with the substitution by a hyperbolic function. So like in catenary problem, minimal surface problem. Yes. So it will so this will simplify.
what do you mean?
So not p, but something like y prime equals squash p or maybe shine p. So it depends on the problem. So I will try to help you. I will rewrite this as y prime squared equals. So if we move it that way, I will get 4 times y plus 2 squared and plus some constant c2. Yes, let it be c2 maybe. I think it doesn't matter. Okay, so this, and then this must be 1. Yes, 1. It is 1. Yes. Okay, and now we should choose them then substitution. I think it must be.
What do I do then? Then you need to find.
Okay, so something like quash, but so it depends on this on C2. How to eliminate it? I don't know. Or maybe try to find C1 from. So another way is to try to to solve this, so to substitute, to substitute these points. Yes, I think y of 0 is must be, so it is, if this is 0, then y must be -1. So
-1, so 1 minus
2. So 0 equals a log, yes, so 0 and root -1 minus c1 over 4. Yes, so this must be equal to 1. And then
c1 is minus
C-minus is equal to x, so that means 1 plus 2 is equal to 0.
yes, minus 8, yes, -8, yes. And so this is the same as root y squared plus 2y plus 1.
Okay.
So, okay, and this will simplify. So this is the perfect square. And so it is the same as 1 plus y plus 1. Yes? And so we get 2x, the solution 2x equals ln 1 plus y 2, yes, plus 2. And then, so it is, or multiply by 2. Maybe it's better to multiply by 2 because we need to solve this for y. And it is easy to solve this for y. Yes, so e to the, yes.
Am I correct at this point?
Maybe. So you have solved this. The solution of this cos, okay. And how is it obtained through cos? So is this the solution of the homogeneous equation or not? Homogeneous equation plus the particular.
Or just C.
See?
Just C.
And maybe it's correct, I don't know, so I may check. Okay, so y of 0 equals 1/3 and y of 1 equals 1/30 squared, so you should substitute them here. And
is my equation of y correct? I don't think
possibly, maybe, I think. So I may have a look. So task number 5 has an answer. And the answer is this 1/3 e to 2x. So I think it's e1, but -1/6 e to 2x is not correct, I think. So it must be something like this 1/3 plus 1/3, not -1/6. Just check. But if you divide by 2, there will be no 2 here. Divide by 2.
Sorry.
Yes. Oh, yes, this one. So this is the equation. The answer. It's not possible. Just a moment. I will have a look. But the answer is there's something wrong, I think. So the answer to your task is sine 2x or sine pi half -1. I don't know why. -1 is correct, but sine 2x divided by sine pi half. Why? But we have lost constant of integration. Where? The constant, it must be a constant of integration somewhere. Maybe through dx, so plus c, so plus c here. Yes.
Okay, but
Plus c2. Yes, we must have 2 constants of integration. So you must add c2 here. C2. And then after this, make a substitution. But maybe C1 is not 0, maybe 0 or not. I don't know now. It was very
I think
And have you obtained the answer? So why? But this is not the answer. So it's just the what is the solution of your? So this one, yes.
but
This.
first, I have some question. First of all, Polo told me this equation. Why is this equation? I don't understand where he got it from. So I came to this point. I get minus 2y tag plus 8y equal to 2 cos x. I understood how I got here.
Okay, so there are two 2 and negative 2, but not cos. Yes, this. And after this, to find a particular solution for a non-homogeneous equation, which is this. Yes. So just it's better to divide by 2.
Yeah. But
you must look yes.
Right.
You must seek this in this form.
But
yes,
why?
with the undetermined coefficients
But I
a and b.
why? How come?
So you should compare. So look at this cos x, and so the answer will be the linear combination of cos x and sin x. It was studied at the last year. Yes. So how to solve non-homogeneous linear differential equations.
Oh, okay.
Yes.
So is this right? This step I found a and b here.
And where a and b?
B is 1/4 and a is y tag over sin x.
So it is impossible. So it must be a number, not this.
But how can?
So how to find a and b? Do you know how to find them?
Well, we have y here, right? So I found y.
It's difficult. I think it's incorrect. Yes, I will help you.
No.
Have you obtained anything? Okay, Kathy, I will give you the book with answers, and you will check the. So it must be. You must obtain this formula: sin 2x over sin pi half. And you will try. And so I will help. Yes, I will help Daniel. So it's incorrect. I think I'd like to I'd like to remove this.
Yeah.
All of this because I think it's not correct. But Follow helped you with the formula a sin x plus b cos x. This is correct. And now to continue, just a moment. Hello? Advertisement, I think. Okay. Y prime equals. So just differentiate these. Sin x, and then y double prime is minus a sin x minus b cos x. And then substitute into this equation, which can be written as y double prime minus 4y equals minus cos x. So is it correct? I will check. Not minus. Okay. So you made a mistake with this sign, so it must be plus. Plus. You have mistaken. Okay. So substitute this. Substitute y given by this formula. Substitute y double prime, and try to find the coefficients.
So this is why, but I have no space to continue, that's why. So can I erase this?
Oh, yes, it's difficult now. It was a bad idea, yes, to solve simultaneously.
Anyone coffee. You had 4 hours to solve this. You hadn't solved it. Why does this right now?
Okay, so I suggest to complete then so the first task, number 4. Next, discuss task number 5.
Which I've already written up. Good.
Yes, and after this, discuss the task solved by Daniel. Let's solve number 4 together. So we must help Kathy to solve it.
We just took the Lagrangian normally.
Or so without this, it's more convenient to solve this without this technique. Yes, sometimes maybe it's better. Yes, maybe. Okay, I will check this. So normally, yes. Yes, it's this minus. I think yes, it's this, and just solve this. Yes, it is more convenient. Yes.
Okay. So,
yes. So let's remove this, I think. So sometimes this formula will not help. Yes, it doesn't help. Now to solve this, so this is a non-homogeneous linear differential equation, y double prime minus 4y prime equals 4, yes. Just a moment, I will check. I maybe. Let's check. Okay. So just substitute this minus. I think yes. No. Sine A equals 0. Yes, and B 1/5. I think it's okay. Yes. And what to do next? So why is this and next, and how to write the answer? This is not the answer to the problem. This is the answer. So this is a particular solution, and how to use this condition, for example. Do you know? No. So you haven't solved this equation, yes, because this is a particular solution, and this is the general solution of a homogeneous. Next, you should add the general solution of a homogeneous and a particular solution. Add them together.
So we take C1 e to the power 2x plus this.
Yes, plus this. Yes, C1 e to 2x plus C2 e to negative 2x plus so minus 1/5 cos x. Yes. Y must be. Minus 1/5, yes. And next, your goal is to find C1 and C2. How to find them?
Well, we can start doing this.
Yes.
So substitute for x 0.
0 for x and pi half for x also. 0 for x and equate to 4/5. Pi half.
Yeah, but then.
Yes. What is cos pi half? What is this? Do you know? The value of cos of pi half.
So, 260 and 89 plus of 90. Plus of 90 is going to be 1.
No, cos. The
Zero.
trigonometric
0.
circle, yes, 0. It is 0.
I'm thinking of the function.
Yes.
Okay.
And what is e to 0
1.
to the power? Yes.
This is basically 5. And cos of 0 is 1.
Cos of 0 is 1.
5.
Yes.
Um,
So rewrite. I suggest to rewrite both equations. Okay, and what about u? Well, maybe. So, did you check the answer or not? What is this your answer?
This is the general equation.
The answer to 1/3 e to 2x, I think, or
But
yes, 1/3. And C1 and C2. Have you found C1 and C2? They must be
to
0. Yes. So the answer is if C1 and C2 are 0 due to this initial condition.
That they're equal to 0.
Sorry, what?
I'm not getting that C1 and C2.
And why? So have you checked or not?
Have I checked?
Just substitute this.
Yes, I've checked.
So if you substitute 0, you will get okay.
Cos of 0, 1 C1 plus
1/3 is okay. If
C1.
C1 and C2, C1 is 0, I think. Yes. Because so if you substitute 0 here, you will get C2 times 0. So and this is eliminated, and then C1 plus 1/3 is equal to 1/3. So C1 is 0. Yes. Okay. And
to get a constant for.
And then so a constant. And what about constant? So you should find a particular solution. So y equals 1, I think. -1. A particular solution for this equation. Y double prime minus 4y equals 4. So y equals -1 is a particular solution. So you must add this -1, -1, -1. And then substitute these initial conditions here.
Okay. So y of 0
Yes. But C2 is also 0, so the answer is 1/3. The answer is 1/3 e to 2x. And the next step is to check that this is actually a minimizer. Yes, so this is a critical point now. And to check that this is actually a minimizer, you must find the difference. Yes, so shall I? So recall that to prove you must do the following. So y plus some variation v, which takes 0 values at the end points. V of 0 equals 0, V of 1 equals 0 also. V of y, where y is given, y is 1/3. Yes, and then find this. So just find the difference and try to solve.
Greater than that.
Yes, it must be greater than, yes. If you will prove that this is greater than or equal to 0, then you will prove them. Okay, this is the answer. I will check. E to y2, so without 2, so just e to 2x. Not this is the consequence. Yes, yes, line. So e to 2x minus 1/5 cos 5x, cos x without 5. Why 5x?
Yes.
Cos x, yes. So this is the answer, and are you able to prove that it is actually minimizer?
Oh no.
No. Yes.
No.
Well, so let's prove with follow, and after this, So he tried to prove that his function y equals 1/3 e to 2x is actually minimizer. So find the difference, and subtract this. So yes, I think it's okay. Sine 2x divided by sine pi half, and then after this, the last step is to show that it is actually minimizer. Okay, let's do it with follow, and after this, we will try to solve your task. Yes. Yes. Okay, and usually it must be shown that so these linear parts. So look here. So v prime. So this is a quadratic part, and this is a linear part. Okay, these three terms constitute the Lagrange equation. So if we consider only this part, so 2y v prime plus 2vy plus 2 e to 2x v dx, this will be Lagrange equations. How to prove this? So we may integrate by parts. Okay, so use integration by parts for this term, and this is equal to the integral from 0 to 1 2y prime dv. It is 2y prime v from 0 to 1, which is 0, because we have this, minus the integral from 0 to 1 2y double prime v dx. Okay, and so if we substitute, if we replace this term by this, we can rewrite this integral in the form, so it will be minus 2y double prime plus 2y, 2y, plus 2 e to 2x multiplied by v dx. But this is equal to 0 because of the Lagrange equations. Yes, so this is 0. And so all these linear parts. So it is not difficult to find linear parts. Yes. So v prime or v raised to the first power. So you must make Lagrange equations from linear parts. Usually they come to the Lagrange equation. But next you should consider quadratic parts. But this form is positive definite. Yes, v double so v prime squared plus v squared It's positive definite. So proof.
So
Okay, is it clear?
I have found out that this part equals to 0.
Yes.
Obviously, square plus square is greater than or equal.
Yes, and so positive definite. Yes, greater than or equal to 0. Yes, because the integral of positive definite part is yes. So proved. Yes. Okay, and next. What? Okay, shall we complete the solution? So no.
I understood.
Okay. How do you want to complete it?
So he has found the solution, but he hadn't proved that it is the minimizer. Okay, shall we prove, or is it? Okay, do you want to prove, or are you tired, or? Okay, let's complete them. So this is the plan. You should proceed in this way, in the same way, to prove. Yes. Just replace the function, the Lagrangian function, by your by the function from your problem. Yes. 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 You must make a Lagrange equation from the linear part of this expression. Yes. This, yes. Yes. So you may proceed in two ways. The first way to integrate by parts. To apply the integration by parts to this term, yes, or if you proceed another way, so another method to prove that the integral of this sum is 0 is to write them. So our equation in the form. Okay, so we have the following. So nabla G and V is actually equal to Ly times V plus Ly prime V prime dx. Or using the integration by parts, this can be rewritten as, so the integral can be rewritten as the integral from Ly times V minus d over dx Ly prime multiplied by V So these are the same, yes? And so if you show that your linear part has this form, then you will prove this, yes? So just this. L, the derivative of L with respect to y multiplied by v. So let's take the derivative of y. So 8y multiplied by v. So 8y multiplied by v, yes? Plus 8 plus 8v. So these two terms are the same. So give y prime times v. And this is the same as this. Yes. Okay. Yes. So this is only for solving. So this operation was made to eliminate v prime. Yes. If we integrate by parts, then v prime goes under the differential, and then they switched. Yes. So these two terms are switched, and so you will get this minus d over dx ly prime, and v is a common factor, and so after this you equate this to 0. But you may use the original variation, yes, the original equation. So it's the same. Use this or use this, and so maybe sometimes it is convenient to use the original equation, yes, the original form.
So this part is for 0 now.
Yes. And what about the quadratic part? I think it's also okay because it is positive definite. Positive definite function, and if we integrate not plus 8v, 8v goes to the linear part. Only 4v squared plus v prime squared. That's all. Dx. So it is greater than 0 for non-zero. And if v is non-zero, it is always positive. So our quadratic part is positive definite, so it's okay. Well, thank you. Yes, it is a minimizer. Okay, let's finish our seminar. Yes. Right. Well, let's stop here.